So continuing the next question, I said 2 moles of N2H4 loses 16 moles of electrons. So using this information, I can say 2 moles is losing 16 electrons. Therefore, 1 mole will lose 8 moles of electrons. And 1 mole loses 8 moles of electrons, and that is nothing but a definition of N factor. So using the shortcut, now we have change of oxidation number into atomicity, which is 2. So we have change of oxidation number is equal to 4. So in that question, minus 2 nunchi, now it has to jump 4 units. So minus 1, 0, plus 1, plus 2. So the oxidation number has to be plus 2. Meeku ichina options nunchi chudandi. If your option 1 is N2O3, N2O4, N2O, and NO, out of these, the answer would be NO, where the oxidation state is plus 2. Okay. Aithe, deentloone slight modification. Going back to the previous question, in the previous question, it was 1 mole of N2H4 loses 10 moles of electrons, and you got the product as N2O3, right? If not N2O3, I could have also given you HNO2. That is also a possibility. So answer up to option A and option B rendu avutayi. Modification to the question would be asking you how many moles of these. So the answer would be 1 mole of N2H4 ante 2 nitrogens. So 2 nitrogens, I would get 1 mole of N2O3. Ade same question, HNO2 kaite 1 mole of N2H4 lo, you have 2 nitrogens. Here there is only 1 nitrogen. So it should give me 2 moles of HNO2. So 1 mole of N2H4 after losing 10 moles of electrons produces 1 mole of N2O3 or 2 moles of HNO2. Ronditlo edaina sare correct. If I change the moles and write 2 here, or if I write 1 here, then they are not the answer. So number of moles kuda correct ga set avvali, not just your product. You have to make sure that your number of moles is also matching if it loses 10 moles of electrons. Okay. So in this question, in the question number 2, 2 moles of N2H4, then how many moles of NO would you get? You would get 4 moles of NO on losing 16 moles of electrons. Okay. So this is your answer. We're already done looking at law of equivalence and calculation of N factors, calculation of equivalent weights, and how to use the law of equivalence to calculate number of moles of substances involved in a chemical reaction. The next use or application of your N factor would be in balancing of reactions. Now, yesterday we've already seen how to balance reactions using oxidation number method. Today, we're going to take it one step further, and we're going to do different types of reactions apart from the ones which we have already covered. So first, a quick recap of what we did in oxidation number method. Now, apart from oxidation number method, there is also another method called ion electron method. I'm not going to cover that now because that's only important from your public exam point of view, but otherwise for JEE, you can use oxidation number method, which is much easier than the other one and much faster. That is more important. More than being easy, it's faster. So quick recap of your oxidation number method. First, we're going to do it for simple reactions, the same reaction that we did yesterday. I'm going to do it for KMNO4 plus oxalic acid reaction. H2SO4 gives K2SO4 plus MnSO4 plus CO2. And water may or may not be given. So yesterday I took water. So today I'm going to skip the water and show you how to do it. So first step is to recognize your oxidizing agent and reducing agent. And among the different elements in it, recognize the ones which are changing their oxidation numbers and write down their oxidation numbers and what they're changing into so that you can calculate the N factors. So quickly calculate the N factor of this as 5 and N factor of this as 2. So this method is also called the crisscross method because we're going to crisscross the oxidation numbers, crisscross the N factors and write them as the coefficients for these substances. Now, once you write them as coefficients, you are not going to touch them. These numbers are now going to be fixed. So no longer touching them once you crisscross. So I'm going to write 2 here and I'm going to write 5 here. And even if you have to put some fractions or anything, please do it on the right side. Antegani, no touching the left side again. And once you do the crisscross method, first balance the elements who changed their oxidation number. So in my case, it would be manganese and it would be carbon. Once you're done with manganese and carbon, next you're going to balance the other elements apart from hydrogen and oxygen, which in this case is potassium and sulfur. So potassium is already balanced. You have to put a 1 here to make sure the entire thing looks balanced. And sulfur, right side you have 3 sulfurs. So left side, please make sure you're putting 3. Now balance hydrogens and check with oxygens, cross check with oxygens, or balance oxygens and cross check with hydrogens. I feel balancing with hydrogens is easier here. So left side, I have 16 hydrogens. So right side, I cannot see the hydrogens. So I'm going to add water whenever I want. What do you mean adding water whenever you want? Wherever hydrogens are deficient or oxygens are deficient, you can balance them by adding water because water is just your solvent most of the cases. So that's why I'm going to write 8H2O. Now you can cross check with oxygens. Left side, you have 8 plus 20 plus 12, that's 40 oxygens. Right side, you have 4 plus 8 plus 20 plus 8, 40 oxygens. So since it is balanced with respect to oxygen also, this reaction is perfectly balanced. I'm going to do another reaction. Now this reaction looks only slightly different from the previous reaction because what I'm going to do now is when ionic reactions are given to you and how do you balance them. Similar style, nothing different, just one tiny step changes, that's it. So your ionic reaction for the above balanced reaction would be this. Permanganate plus oxalate plus H plus give you Mn plus 2 plus CO2. I may or may not write water, that's up to me. Okay, so ila is third word. When he gives this, your initial steps are the same. Please calculate N factors, crisscross and fix these. So ikkada 2 fix, ikkada 5 fix. After that, the next step is also same. Balance the manganese, balance the carbons. Now, here your step is going to change. The next step you're going to do after balancing manganese and carbon is balance hydrogen by checking the charges. Balance the charges. After you're done balancing manganese and carbon, balance the charges by adding H plus on the appropriate side. So left side I have -2, -10, and right side I have +4. In order to make -12 equal to +4, the number of hydrogens that you have to add are 16, such that -12 plus 16 becomes equal to +4. So I added 16 hydrogen, 16 H plus. So your charge is now balanced. So after charge balance, now you have to balance hydrogens again. Okay. So what did I do? I first did crisscross. Then I balanced manganese and carbon, which is the same as before. The next step has changed. Earlier, I balanced potassiums and sulfurs. Now, instead of this step, I'm just balancing charge by adding H plus, appropriate number of H pluses. Once your charge is done, now pakka balance hydrogen followed by oxygen. Now, how do you balance hydrogen? By adding water wherever necessary. So left side, I have 16 H plus, right side, nothing. So I'm going to add 8 water. Now cross check with your oxygens. I'm sure they're balanced. Left side 8 plus 20 right side 20 plus 8. So oxygens are balanced. Now this is how you would balance a complete ionic reaction. Let's balance another reaction. This time I'm going to take a different reagent. Cr2O7 2- plus iodide ion gives Cr plus 3 plus iodine. Again, please write the n factors. Now, since I can calculate them quickly, I know the n factor is 6 and the n factor for this is 1. So on crisscross, you're going to get 1 here and 6 here. Next step, balance chromium and iodine. To balance chromium, I'm going to put a 2. To balance iodine, I'm going to put a 3. The next step, balance the charges. On the left side, the charges are -2 and -6. The right side charges are +6. So left side is -8 and right side is +6. So in order to make the charges equal, I have to add 14H+. Now your charges are balanced. Go ahead next to balancing hydrogens. So on the right side, I'm going to put 7 water and cross check your oxygens are already balanced. So this is your balanced equation from oxidation number method. This is also an ionic equation. This is how you would balance a complete full ionic reaction. Now sometimes he might not give you a full ionic reaction and he might give you only half a reaction. Ante only oxidation half or only reduction half. Now from the previous example itself, if I take only the reduction half reaction, he'll give me this. And how will he pose these questions? He'll say to balance this half reaction, how many H plus have to be added and on which side? He might ask this question, how many H plus have to be added and on which side? Now for these reactions also steps are very similar. Your first step would be calculate N factor. Now the N factor for this is 6. Write the 6 electrons on the appropriate side. Now you know that this substance is an oxidizing agent, so it is getting reduced. Reduced and it is accepting electrons. So how many electrons are there? So I have to have 6 electrons based on the definition of N factor. What's the definition of N factor? Number of moles of electrons lost or gained kada. So that's why 1 mole of Cr2O7 2- is gaining 6 moles of electrons. So that's your first step. Write the N factor, calculate the N factor and write it as the number of electrons lost or gained. After that, balance chromiums 2. After this, balance charges, same as before. Add hydrogens wherever necessary and balance the charges. So left side, I have -2 plus -6. Right side, I only have a +6. So in order to make these equal, I have to add 14H plus on the left side. And then balance the hydrogens by adding water. 7 water. Cross check with oxygens. So this is your half reaction balancing. Let's do another half reaction balancing. This is half reduction reaction. Let's do half of an oxidation reaction. Let's do C2O4 2- converting into CO2. First step, N factor and write the appropriate number of electrons based on that. N factor for oxalate ion, it's going from +3 to +4, change is 1, 2 of them. So N factor is 2. So that N factor 2 has to be written as loss of electrons because this is oxidation process. Next step, balance carbons. Next step, balance charges. Left side you have 2-, right side you have 2-. So you're not going to add or remove any H plus. It's done. Check oxygens, already balanced. So my reaction is done. So this would be a very simple one. Let's take a slightly complicated reaction. Again, a half reaction. Oxidation itself. This time I'm taking I minus becoming IO3 minus. Please observe carefully what my steps are. I minus becoming IO3 minus, first calculate n factor. That's always the first step. When I calculate n factor, it's going from -1 to +5. So n factor is 6 and it's loss of electrons because it is oxidation. Next, balance your iodines. It's already 1 on the left side. So right side is also just 1. Now balance charges. Charges by adding or removing, adding H plus on the left or the right. So right side it is 7 electrons. So obviously my 7 electrons on the right and -1 on the left. So you have to add 6 H plus to the right side. So 6 H plus there, which means you are going to add 3 water to the left side. Now cross check with oxygens, everything is balanced. So this is your perfectly balanced half reaction. So in the question, he might give you a half reaction or a full reaction or an ionic reaction also. So we've done all the 3 types. We did a full reaction, we did an ionic form of the reaction, and we also did half reactions. Okay. Now, when you're balancing reactions, it's not always necessary that he will ask you to balance it with H plus. Sometimes he might ask you to balance with OH minus also. In such cases, you will have an extra step. When he asks you to balance with OH minus, just 1 step extra. After you're done writing this, let's look at the last reaction. Just add 6 OH minus on the right and on the left. Why 6? Why not any other number? Trying to remove H plus. I'm trying to make sure I don't write H plus. So right side I see 6 H plus. Therefore I'm going to add 6 OH minus. And then write them together. You're going to have 6 water here. And here you already have 3 water. So this 3 gets cancelled with the 6 here to give 3 here. So your net reaction is now iodide plus 6 OH minus gives IO3 minus plus 6 electrons plus 3 water. Okay, just writing it together now. I had 3 water earlier. I had 6 H plus earlier. That was one way of balancing. If they ask you in the question, do not write or do not balance in acidic medium, balance in basic medium, I'll just add 6 OH minus so that this together is now 6 water. Simultaneously, please make sure you add it to the left side also, 6 OH minus. Now, in the resultant reaction that you have, see if anything is common and it can be cancelled. Like in this case, 3 water can be cancelled with 6 water to give 3 water. So your net reaction becomes, after cancelling, you're going to get I minus plus 6 OH minus gives IO3 minus plus 6 electrons plus 3 water. And your original reaction in case of acid balancing was this. If it's acids, you would have written the first way. If it is in basic medium, you're going to write it in the second way. Both of them are balanced. So what all did we cover till now? We covered full reactions. We covered ionic forms of the reactions. We covered half reactions. And in any case, if they ask us to balance with bases, how to balance. So this process is enough, or these methods are enough to balance any given reaction for you. Now, this is something we've already done yesterday. I just extended it slightly. Next, what we're going to do is balance disproportionate reactions. Now, these are not going to be any different. They're very similar to your previous method of balancing itself. I think I'm going to show you disproportionate reactions, not the full reactions. So what is your disproportionate reaction? Chlorine plus, I'm going to take this example, gives NaCl plus NaClO3. The steps are going to be the same as it is, no different. There is no change in the steps, as it is exactly same steps. But what is different here is, your first step, you're just going to slightly modify it. How do you slightly modify it? Now I have to find n factors, kada? So it's changing from 0 to -1. It is also changing from 0 to +5. Now, if I want to do crisscross, I need two reactants. But both my reactants are chlorine itself. So I'm just going to write chlorine twice. That's the only modification I'm going to do. Instead of writing the upward arrow and downward arrow both from this chlorine, I'll just write one more chlorine additionally and do the steps. After this, after you make a difference in the two chlorines, the steps remain the same. Please look at the steps. Step number 1, write the n factors. The n factor for this one, the reduced chlorine, it's going from 0 to -1, changes 1, and there are 2 chlorines. So n factor 2. The oxidized chlorine is going from 0 to +5. So change is 5, and there are 2 chlorines. So change is 10. So your n factor for this one is 2. The n factor for this one is 10. So now crisscross and write down. So you're going to write 2 red chlorines plus 10 black chlorines plus NaOH gives NaCl plus NaClO3. Now I want to write red on the right side also, so that the red has to be matched with red only. Now, just because I put some color to chlorine doesn't mean adi kuda color eskundi rutadan kaadu. I'm just making my job easier so that I don't make a mistake. If you have colored pens, write it with colored pens. If you don't, please make sure you're balancing E chlorine to E chlorine, E chlorine to E chlorine. Don't interchange and balance. You can't just say total chlorines I'll balance. No. Make sure you're balancing the upward arrow chlorine with upward, the downward arrow chlorine with downward itself. Because this chlorine is the reduced one. This chlorine is the oxidized one. Okay. So they do behave differently. So left side you have 4 red chlorines. So I'm going to put a 4 here. And you have 20 black chlorines. So I'm going to put a 20 here. Now we're done balancing chlorines, the atoms which changed. Next step is the same, balance the ones who are not changing, which is sodium here. So right side I have 24. So left side 24. Next, balance hydrogens and check with oxygens, or balance oxygens and check with hydrogens. So I'm going to balance hydrogens first, which is easier for me. Left side I have 24. So right side I'm going to put a 12. Now after you're done, just because I wrote them separately, they're not going to be separate. So you can write them together now. So basically you have 12 chlorines. Observe the reaction carefully. I'm going to make a slight change, slight modification, small tweak. I have a common factor. I hope you can see that too. So just remove that common factor. 4 is your common factor. So 4 3s are, 4 5s are, 4 6s are, and 4 3s are. So that now your net reaction is 3 chlorine plus 6 NaOH gives 5 NaCl plus NaClO3 plus 3 water. So this is your net balanced reaction. Obviously, we are not idiots. We're not going to leave 12, 24, 24 and 12 like that. I'm taking a common factor and writing the net reaction. So the steps have been the same. Aite, dintlo one more different type of question I can ask after you finish balancing. Apart from the balancing, I can additionally add another bit to the question. What is the ratio of reduced chlorine to oxidized chlorine? Or what fraction got reduced? What fraction got reduced, or what is the ratio of reduced to oxidized? Look at the final reaction. Out of the 6 chlorines that you have, 5 got reduced, -1, and 1 got oxidized. So the ratio of reduced chlorines to the oxidized chlorines is 5:1. So what fraction got reduced ante? 5/6 got reduced and 1/6 got oxidized. You are able to write this after the final step. So look at the right side and write it. Right side I can see 5 chlorines are reduced and only 1 chlorine is oxidized. So this final question kuda adagochu nenu. Apart from asking you to balance, I can make it a multiple choice question and ask you how many reduced chlorine, how many oxidized chlorine also. I'm going to do one more example in disproportionate so that you get familiar because it's an important model. I want you to pause the video as soon as I give the question. Pause the video, try the question and cross check if it is matching with what you did. Okay. I'm writing the equation. Phosphorus plus NaOH gives PH3 plus NaH2PO2. In this question, add water if it's necessary to the left or the right and balance the equation. Balance this disproportionate reaction. Pause the video now and then play it after you're done solving the question. So I'm solving the question now. I have phosphorus reducing and oxidizing. So like I said, I'm going to write 2 phosphorus, 1 red and 1 black, and I'll change this to red. So please connect and use if you don't have 2 colored pens. So this is going from 0 to +1, change is 1, 4 of them, so n factor 4. This is going from 0 to -3, change is 3, 4 of them, n factor 12. So crisscross and write down. 12P4 plus 4P4 plus NaOH gives PH3 plus NaH2PO2. Just changing my phosphorus into red. On crisscross, you got these coefficients. So go ahead and balance. 12 fours are 48 reds. So 48 here. And 4 fours are 16 blacks. So 16 here. Next, balance the sodiums. Sodiums are right side 48. So obviously I'm going to put a 48 here. Next, balance hydrogens or oxygens, up to you. I'm going to go for oxygens this time. Left side I have 48. Right side it's 48 into 2. So I have to put 48 water on the left side. Cross check with hydrogens. It's 48 plus 2 into 48. Right side 16 threes are 48 plus 2 into 48. So the hydrogens are also balanced. So this is your perfectly balanced equation. Obviously, I'm going to do the final tweak where I write both the phosphorus together as 16P4. And then I can see 16 is a common factor. So 16, 3s are 16 and 3. So your final equation is P4 plus 3 NaOH plus 3 waters gives you PH3 plus 3 NaH2PO2. This is your final balanced equation. But that's not the end of the question. I also want to know what is the fraction of reduced, fraction of oxidized. Out of the 4 phosphorus atoms that are there, 1 got reduced. So 1/4 is reduced. Out of the 4, 3 got oxidized. So 3/4 got oxidized. So if someone asks me for a ratio, it's 1:3 reduced to oxidized. Or if they ask me for what is the fraction of reduced, it is 1/4, fraction of oxidized, 3/4. So that's it. We're done with balancing of reactions. We did ionic reaction, we did a complete reaction, we did half reactions, and we also did the disproportionate reactions. So this is the end of your balancing of reactions.